All right, for the second part of this video, we're going to go in and talk about a complement. So A prime is called the complement of A. So event A prime is called the complement of A. And we use this basically when there's a not in the problem. So when it says you want not something, so when they say the word not, and we're going to do an example shortly. So the formula is the probability of A prime is equal to 1 minus the probability of A. So it's basically like the not is equal to 1 minus it is. And this should make sense because probability has to equal 1, so you cannot get any value greater than 1. So if we're trying to figure out some piece that's missing, you can just do 1 minus that piece, and that'll give you the missing information. So for the examples here, we are going to have a card is randomly selected from a standard 52 deck cards. I did post online the deck of cards. Sorry about that, I ran away. So it looks like this. So these are not in color, I apologize for that. But basically hearts and diamonds, these are all red cards. And then you have your clubs and your spades are blacks. It tells you how many of each card you have. There are 4 suits, okay? So 1, 2, 3, 4 suits, 13 cards in each suit. There's 52 cards total, half are red, half are black. These cards over here are considered face cards, Jack, Queen, King. So if you've never played cards and I ask for face cards, it's only referring to these, which there are 12. Okay, so again, I did post that, so use that to help you on homework. So for instance, this next example says you want the probability of not a king. So we're going to do the probability of not king is equal to 1 minus the probability that it is a king. And the main reason we use this excuse me, is to count less things because there's far few kings than not kings. So there are 4 kings in a deck, so 4 out of 52. So 1 minus 4 over 52 is going to be 48 over 52, which reduces to 12 over 13. So it's very probable that you will get a not king when you randomly select. So now we want not an ace or a jack, so probability not ace or not jack. We're going to use that same prime. We're going to do 1 minus the probability that it is an ace or a jack. So for this one, the number of aces in the deck, there are 4. So 4 out of 52 plus the number of jacks is also 4. And I'm keeping it in parentheses because I need to subtract the whole quantity. So that's going to give me 1 minus 8 over 52, which is 44 over 52, which reduces to 11 over 13. Now to see how this all ties together for our last example, we're going to just be rolling 1 6-sided die, so thinking about the different possible outcomes that can occur. So we want rolling a 4 or a prime number. Keep in mind, prime numbers, 1 is not prime. So prime numbers would be 2, 3, and 5 on a dice. The reason that 1 is not prime is the definition of a prime number is it must have 2 distinct factors. 1 times 1 is not distinct. They are not different. So we're not going to use 1 as being prime anywhere through these examples. So we want the probability of rolling a 4 or a prime. So it's going to be probability of a 4 plus probability of a prime minus the probability of a 4 and a prime. And as you get good at these, you'll notice that 4 is not a prime number, so this value here is going to be 0. So I may not even need to write it in, but you always want to keep it in the back of your mind. So the number of 4s on a dice is 1, so 1 out of 6. The number of primes, 1, 2, 3, so 3 out of 6. And then we said we have none that are in common. So 4 over 6, which reduces to 2/3. Now we want even number or prime number. So we still have our prime numbers from the previous example. Even number, 2, 4, 6. So So we want probability of even or prime. Probability of even plus probability of prime minus even and prime. So evens is 3 out of 6. Primes was 3 out of 6. Plus any that are even and prime. So if I write the primes back down here again so you can see them, you're going to see that we have the number 2 in common. They both have this 2. Sorry, that's my left hand. That's the and. That's the one that's here, this last piece. So we're going to take out that 1 because, again, we cannot overcount. So we're going to get 5 over 6. Rolling an even number or 1. So probability of an even number or the number 1. So probability of even plus probability of 1. We know even numbers aren't 1, so I'm not going to do the minus. So even numbers, there's 3 out of 6. 1, there's just one number 1 on a die. There is, like we said, nothing in common, so you can take off that last piece. Or you can put a -0. It's completely up to you. Rolling a 6 or a number less than 3. So numbers less than 3 on a die are 1, 2, and 3. And then again, a 6 is just a 6. So we'll do the probability of 6 plus the probability of less than 3. Sorry, I've got an itchy throat. So we have 1, 2, and 3, which are not the same number 6. So they don't share anything in common. So you won't need to do, again, this minus piece. It'll be a -0. But again, if you want to write it, go for it. So this will be a 1 over 6 plus a 3 over 6. Tiny error. 3 is not included. My bad. Less than 3 does not include 3. So let's make this a 2. Whew. So then 1 plus 2 will give us 3. So 3 over 6, which is 1/2. Now we want even number and a number greater than 5. Greater than 5 is just 6. Even number, we've done that one many times. So even or greater than 5, so probability of even plus probability of greater than 5 minus the probability of even and greater than 5. So since 6 is an even number, I know there's going to be a little bit of overlap. So even is 3 over 6. Greater than 5 is 1 over 6 minus the one they share. So you're back to 3 over 6. Or 1/2. Last one, rolling an odd number or a number divisible by 3. So odd numbers, 1, 3, and 5. Divisible by 3 would be 3 and 6. So probability of odd. Whoops. Hang on one sec. So probability of odd or divisible by 3. And divisible just means divides into evenly. So odds 3 over 6. Divisible by 3, 2 over 6. And then don't forget to go back and see there's this 3 here that repeats. We have to take that out, so it'd be minus 1 over 6. Giving us 4 over 6, which is 2/3. And that concludes the notes for today.